Someone want to volunteer to read the paragraph that starts this, Jordan?
Roller coasters can be scary, but fun to ride. Below is the graph of heights reached by cars of the Thunderball roller coaster. Over its first 1,250 feet of track, the graph displays a function because each input value has one and only one output value. You can see this visually using the vertical line test. Study this graph to determine the domain.
Okay, so there's a couple of things it talked about in here. First, it talked about the vertical line test, which I kind of touched on the other day. We're going to talk about in more detail now. Everybody take your pencil and put it vertically on the graph, which means straight up and down. And just kind of move your pencil side to side across the graph. Does your pencil ever touch more than one point at a time? No. So that means that it passes the vertical line test. That means it is a function. So let's go ahead and write this, if your pencil doesn't touch more than 1 point at a time, it is a function. So if your pencil doesn't touch more than 1 point at a time, it is a function because none of the x values repeat. There's no two x values on top of each other that would be the same. So that makes this a function. The last thing it said was it wants us to determine the domain and range. So first let's talk about the domain. What does the domain normally mean? Input or the x values. So what is the input or x values on this graph?
Distance along the track.
Right, so the x coordinates will be our domain. What is the smallest x value on the graph? And I'm not talking about like the number line. I'm talking about on the graph itself. What is the smallest x value?
252.
0. So this graph goes all the way, starts at 0. And then what is the furthest along the x it goes? What's the biggest distance it goes? 1,250. So if we look at this next little paragraph, it says the domain gives all values of the independent variable. In this case, the distance along the track in feet. So the domain values are graphed along with the horizontal or x-axis. The domain of the function above can be written in set notation. So they just took what we just said, which was the domain starts at 0 and it ends at 1,250, and they wrote it as a compound inequality, which we just learned about. So this is saying all of the x values, all of the domain, is between 0 and 1,250. And it says you can read this set notation as the set of all real values of x between 0 and 1,250. What's most important to know is those numbers. You need to be able to find the two endpoints where the domain starts, where the domain ends. Then it says the range gives you the value of the dependent variable. So the range gives values of the dependent variable. In this case, the height of the roller coaster above the ground in feet. The range values are graphed on the vertical or y-axis. The range of the function can be written in the set notation. So what is the lowest number? What is the lowest the roller coaster goes?
0.
Does it go to 0?
10.
No, it starts at 10. And what's the highest the roller coaster goes? 110. So this is the range, the y values. So So it starts off at 10 and it goes to 110. And they read this as the set of all real numbers of y, because the y is the range, between 10 and 110 inclusive. Inclusive means you are including those numbers. So let's go ahead and turn to the next page. And we're going to make some notes at the top of page 82. There's a whole bunch of vocabulary going on up here. So it says, the graph above shows data that are continuous. The points in the graph are connected, indicating the domain and range are sets of real numbers with no breaks in between. So continuous, it means that all of the points are connected. So it can either make a line, it can make like an up and down thing, but it just means the points are connected. So let's just kind of write that in our own words, that continuous is a graph that have points connected. A graph of discrete data consists of individual points that are not connected by a line or curve. So nothing is connected. This is just random, not random, but it's just points or dots. There's no connection between those dots. And then there's some other useful pieces of information that we are going to look at on this graph. The y-intercept. What does the word intercept mean, Jordan? Where they cross paths. So the y-intercept is where the graph crosses the y-axis. That's where it crosses the y-axis. The relative maximum is the greatest value of the y's, but not the endpoints. So when we're looking at a graph, it's all of the high points. It's the maximum, that means the highest, so it's all high points. But it does not include the ends. So I'm going to just say no ends, no endpoints. The relative minimum, so what is minimum? Small. So it is all of the low points, but not including the endpoints. So all low points, but does not include the endpoints. And that's what this little section says. It's saying that the relative minimum and relative maximum cannot be the two ends of the graph. So these next 5 questions, we're going to have to flip back and forth a little bit to that previous page to look at the graph. And so this first question is asking, what is the y-intercept on the graph? So let's flip back to the graph. So y-intercept is where it crossed the y-axis. Where does it cross the y-axis?
Teacher, time interruption. Tiana, Tillman, report to the front office.
Where does it cross the y-axis? Which one is the y-axis?
The height above ground.
The height above ground. It's the vertical axis. So where does it cross that axis? So what is that as an ordered pair? It is good. It is 0, 10. So this, we're going to go ahead and label it, is the y-intercept. It's the y-intercept because it's where it crosses the y-axis. And so we're going to go back. Do you have a question? There is. And we're not going to talk about it today, but there is an x-intercept. So what is the y-intercept? It is, we said 0, 10. And what does it represent in this situation? So what do the x values represent? The x. So the x, it's 0 feet along the track. And what does 10 represent? The height. So when the roller coaster starts, it starts where? it starts at 10 feet above ground. So the roller coaster starts at 10 feet above ground. Let's see. So the roller coaster starts at 10 feet above the ground because 0 tells us the distance along the track, and and y, which is 10, tells us how high it goes. It says identify a relative maximum. So relative maximum means what? Maximum means highest. So relative maximum means we're going to list all of the high points. And when we do that, we're just looking at the y values. So what's one of the high points? Well, this is the first one, and that's at what? 110. And what is this one? Yeah, it looks like it's about 90. So these are the relative maximum points. These 2 points here. Those are both relative maximum points. So that was just 110 and 90. Then it says the absolute maximum. So we haven't talked about absolute. Absolute maximum means the very highest point. There's only one of those. Right, it's 110 because we know that the relative was 110 and 90. Those are two of the highest points. But the very highest point, as far as it goes up, is 110. And it says interprets its meaning in the context of the situation. What does 110 mean, Jordan? So so the highest the roller coaster goes is 110 feet above the ground. Okay, now we need to look for a relative minimum. So that is all of the low points. So let's go back to the graph. What are all of the low points?
For y?
Yes, the y points.
10, 30.
Okay, what do we need to exclude? What did we say we exclude with relative?
Oh.
The endpoints do not count. So I cannot include these 2 points. So how many relative minimums do I have? 1, which is what? 30. So this is our relative minimum. What is the absolute minimum? Okay, so absolute actually does include the endpoints. It is different from the relative. So yes, it is 10. So absolute can include endpoints. And then what does that mean in this situation?
10 is the lowest you can go on the roller coaster.
Right. The lowest the roller coaster goes is 10 feet above ground. Any questions so far on the key features of the graph? Okay. So suppose you got on a roller coaster called Cougar Mountain, that immediately started climbing the track in a linear fashion shown in this graph. First, they want us to identify the domain and range. So the domain, remember, is the x value. What is the smallest x value? 0. So I know it starts at 0. What's the highest x value?
175. Oh, X value.
X value. 200. And I write this as a compound inequality. So 0 is less than or equal to x, which is less than or equal to 200. Because all of the x values, the domain, are between 0 and 200. Then I need to look at the range. What is the smallest y value on the line itself? 0. And I'm going to make it less than or equal to y because I'm talking about range, and that's y, not x. Is less than or equal to what is the greatest y value on the line itself?
255.
So we don't want to look at these numbers on the side to just look and say, well, 250 is the highest. That's not right. I need to actually look, where does this graph go as the highest point? And that would be 175. What is the y-intercept? Good. 0, 0. That's where it crosses the y-axis. It crosses right down here. That is the y-intercept. First, it wants the absolute maximum. What is the absolute maximum, the highest of the highs? 175. This graph could go on forever. All I really want to know is where the actual line on the graph stops. I don't care about the numbers where they stop. And then the absolute minimum. 0. Do you think it has relative maximum or minimum?
No, there's only 2 points.
There's only 2. Well, where is the maximum? It's an endpoint. So, no. Both the maximum and minimum are endpoints. Oh, you're going to skip number 10. We're not going to talk about extrema for today. So let's go ahead and turn the page. You have a check your understanding on the top of that page. So take a couple minutes by yourself and do the check your understanding. All right. The graph below shows 5 points that make up a function h. Is the function continuous? Anyone?
Yeah.
Why not?
Because not all of the points connect.
The points do not connect. So the points do not connect, so it cannot be continuous.
Yeah.
Connect would be like this graph down here is continuous because all of the points are connected.
Oh.
But these are just like points that don't have any line connecting them. So that's not continuous. So what is the word for a graph that is not continuous? Flip back and look.
Not a function.
That wasn't the word. Is discrete. Good. So this graph is discrete. The points do not connect. It says this is different. It's not talking about this graph anymore. A function has 3 relative maximums. -2, 10.3, and 28. One of them is also the absolute maximum. Which one is it?
28.
28, because it's the highest of the highs. So that would be 28. All right. These you kind of had to think about. Tell me whether each statement is sometimes, always, or never true. A relative minimum is also an absolute minimum.
Sometimes.
Sometimes.
I have that written.
So it is sometimes true. What disqualifies it? Why does it make it
If
sometimes?
it's an endpoint, then it can't be relative or relative.
Right.
minimum.
The relative minimum, it will never be an endpoint, but an absolute minimum can. What about an absolute minimum is also a relative minimum? That's also sometimes basically for the same reason. It has to do with the endpoints because relative minimums cannot be endpoints, but absolute minimums can. All right, now we're going to talk about a different situation. Tom hiked along a circular trail known as the Juniper Loop. The graph shows his distance d from the starting point after t minutes. So first we need to identify the domain and range. So what is the domain of this function? What's the smallest point of the x's?
0.
0. So 0 is less than or equal to x, which is less than or equal to what is the highest point of all the x's? That's not 150.
I know.
This goes past 150. What is this counting by?
20.
No.
No. 30. Sorry.
Every 2 lines is 30, so every 1 line is 15. So that makes this line 165. So the smallest x value is 0. The biggest x value is 165. Then the range. What is the smallest y value? 0. So 0 is less than or equal to y, which is less than or equal to, what is the highest y value?
7.
7. Good job. That is the top of the graph. What is the absolute minimum? What is the lowest point?
0.
0. And what does that represent in the context of this hike?
No distance from the sun.
So, right, it's where he started. Where Tom started his hike. And then on the top of the next page, number 17, says in this function, the absolute minimum corresponds to 2 points on the graph. What are those 2 points? So what are the 2 coordinates of the 2 lowest points? What is this first one? 0, 0. And what is this one?
65.
What do we put first, x or y?
Oh.
X. So 165, 0. So for number 17, the 2 lowest points are 0, 0,
Yes, could I get Tyron Burnett to check out, please?
and then
Tyron
165, 0. And what do those represent in the situation?
The time.
So it's his, we already said 0 was his starting point. What is 165, 0?
Time in minutes.
And what does it represent in his journey? His end. So Tom starts at 0, 0, because that was 0 minutes in, and he went 0 kilometers, and ends at 165, 0, because he traveled back to where he started. He made a circle, so he went 165 minutes, and he was back to 0 kilometers from where he started because he ended up back where he started from. Identify the absolute maximum. So where is the highest point?
At 7.
Right, at 7. The highest point is 7. And what does that mean in the context of this situation?
The distance from start.
What is the furthest distance he traveled from start? 7 kilometers. So Tom traveled 7 kilometers away from where he started. All right, this one gets a little more tricky. What points on the graph correspond to the absolute maximum? So, is there just one point that's the highest point? No, it doesn't ever like peak like this where there's just like one high point. So, where does this high point start? What is this coordinate right here? X before Y.
7.
Okay, so we'll call that 75, 7. And where does this high point end? 105, 7. So it says what points correspond? So between 75, 7 and 105, 7. And then we need to think about what does that mean on his hike. So what number is changing? The X, which is time. So the time kept going, but what does the Y stand for?
Distance.
Distance. So his distance stayed the same while his time kept going. So what does that mean happened on his hike?
Break.
He took a break. So between 75, 7 and 105, 7, Tom took a break.
Took a lot of breaks.
Identify any relative minimums for the function on the graph. Any low points.
Lowest is 5.
Other than the endpoint?
We can't write. Relative means no endpoints.
5.
So just 5 is the only relative minimum. And then it says identify relative maximums. And so when we're talking about relative maximums, we can kind of talk about the turning points. So for this part of the graph, what is the maximum? 5, because it went up here to 5. So this actually counts as a relative maximum and a relative minimum. So it's going to be 5 and 7. All right, y'all have about 2 minutes. Do the 22 through 24 for check your understanding. Yes. 22. What are the independent and dependent variables for this function representing his height? So first, what is the independent variable? I'm here on both. So independent was the x coordinate. So that would be what? Time. And then what is the dependent variable? Distance. Independent means doesn't depend on anything. Time doesn't depend on anything. Time's going to keep going no matter what. The distance traveled depends on how much time has passed. Number 23, explain how to determine the maximum and minimum. Somebody want to raise their hand and tell me how to determine maximum and minimum of a graph? Faith.
Relative or like the absolute?
Just any of them.
You gotta find the lowest and the highest points.
Good. So find the lowest and highest points. Is it possible for a function to have more than one absolute maximum or absolute minimum value?
Yes.
Absolute?
No.
No, because absolute is the one and only high or the one and only low. So no, it is the highest or the lowest of the whole graph.